Hi everyone, welcome to our session today, part of the AI show. We are on the third session, and today we're going to talk about models fine-tuning. First, before we start, I wanted just to present myself and the team that's working with me together to deliver this session. So my name is Moria. I'm managing the Reactor team based in Israel. Together with me is Jordan Dor, that's also working in the Reactor team, and at this time, developer and startups go-to-market for Southeastern Europe. She will also speak to you soon, so you will have a chance to meet her during the sessions. Before we start, I wanted to talk to you a bit about the Reactor. So for those of you who are new to this session and didn't join us previously and new to the Reactor community, the Reactor is basically community spaces for developers where they can come and learn through online and in-person events and skilling opportunities that we provide for the communities. We have 12 locations that we have physical hubs, physical technical hubs. But other than that, we provide learning opportunities online every day around the world. So if you scan the QR code that you see now on the screen, you can visit our website, and then you can have a look at the list of events that we have and join the one that's most relevant and interesting for you. Before we start the session, I just wanted to highlight the code of conduct that Microsoft Reactor has. So please be aware, even though it's a virtual event, to be kind and respectful to each other also during the chat. Please take a moment to read this code of conduct. I'm going to pass it over to Adi now to tell you a bit more about this AI series and about today's session. Adi, over to you.
Thank you, Moria. Hey, everyone. I'm so excited to be here today on our third session. So what we had till now? In the first session, we discussed about Azure OpenAI and cognitive search. And last week, we presented some best and cutting edge opportunities for developers to utilize GitHub Copilot and productivity to enhance your work day to day. And in this session today, we're going to dive in about models fine tuning. So I hope we have a lot of data scientists in the crowd and also TDM. We're going to start in a early, on less mature models and understanding. And then we're going to do a deep dive into some case studies. Moving forward, next week, we're going to discuss about gaming and OpenAI and how you can take the OpenAI into specific industries like gaming. And after that, we're going to speak about how to use AI through Power Apps and low code, no code. And in the last session of this series, we're going to speak about cognitive services and see a lot of interesting case studies. So if you haven't, by any chance, registered to the series, scan this QR code to join us. We will not move on to the next session, to the next slide before making sure that all of you are familiar with Microsoft Learn. Microsoft Learn is our platform for you, TDM developers, data scientists, IT pros, to learn and get the new certificate, new learning and path to learn new skills by gamified way. It's free, it's interactive, and you should definitely utilize and try it even starting today, and also schedule time in your calendar to learn new skills each week to get adapted to the new world that we are living in. We also drop on the comment link to Microsoft Learn. So with that, I'm moving the stage to Dima, which is our AI product marketing lead in SEMA, that will present himself, and also it's a great honor to have you with us. Thank you so much, Dima, for taking the lead and hosting this session today.
Thank you very much for the introduction. So again, introducing myself, I'm Dima Turchin, and I'm working for quite several years in AI, let's say, technology market. So I started to build my first AI model back in 2002. And since then, I was working in different roles, most recently as artificial intelligence product marketing lead for Central and Eastern Europe. And the last 2 months as my role has changed and increased. So I'm now covering like 100 plus countries for the artificial intelligence product marketing. And my role today is very small. So I will be with you. I will be looking at the comments. And if you will have questions which I can help address, I will definitely do that. But really, my role is to moderate, to introduce the other speakers who have prepared amazing content for you. So I think today's topic about models fine-tuning, as well as some things which are not necessarily fine-tuning, but things like prompt engineering, you'll see more coming forward, how we can make models answer or create content or create responses in the way which you want them to respond, not just act on how they were trained. This is called fine-tuning. So we'll have two sessions. One is done by my colleague Talila, and she will actually be the first speaker today, covering in general, like what is fine-tuning, how is it built, so that after that session, I believe you will be more familiar with the concept of how the fine-tuning is done on different kinds of models, including the new generation models. And the second speaker will be Alan, who is our machine learning engineer from Microsoft, super experienced in fine-tuning the models, and he will share amazing case of fine-tuning the language models, the large language models of the new generation. And he will speak a little bit more about things like prompt engineering versus fine-tuning, and really give you an overview and a great example of how can this be done for your tasks. With this, I will just leave floor for Talila and Alan, and I'm staying here with you in the comments. Feel free to ask questions, which we will try to address during the presentation. Thank you very much.
For the great introduction and for setting the ground for the session. Hello, everyone. I'm Talila. I'm in the part of the data and AI
Start
team
with the first
here in
session.
SEMA. And I can call myself a data scientist. I've been doing this for a while, for several years now, and I love this part. And I love building models from scratch. So hopefully during this session, I'll show you a little bit about what it takes, and also what it in real life, what does a day in the life of a data scientist look like, right? So today we're talking about model fine-tuning, which is a core aspect of building models. You probably will spend most of your time fine-tuning your models, and then once you're done, retraining them again and fine-tuning them again, because a model is actually a living organism. You never stop improving them. You never stop fine-tuning them as long as you keep using them. So that's a very core topic. So in my session, what I will do is, first of all, I'm aware we have a diverse crowd. So I will tell you a little bit about the machine learning process. There are quite a set of steps. So whether you're building a super advanced AI that can generate some content, or you're doing a time series analysis or doing some customer segmentation, the same learning process is there with varied steps. So let's go over it. And then we'll dig deep a little bit. When we talk about models and parameters, what do we mean exactly? And parameter tuning, let's see how it works. And I have some demos for you in Azure ML. I hope you are familiar with the tool. If not, that's going to be a good opportunity for it. And then we'll take it to the next level with something called Auto ML, and I'll have a demo for you as well. So let's see how it goes. I'm planning for about 30 minutes of content. Hopefully we'll stay on time. So let's dive in. So let's talk about machine learning lifecycle in the real world. And what you will notice here is that there's a lot of cycles, a lot of circles, because it's a continuous process. And you could take it into 3 steps. The first one is when you're prototyping. You don't know quite yet what your model is going to be, what algorithm you're going to use. You're still experimenting with your data. So that would be your prototyping phase. At the end of it, and that's the part that I will show you in a second, you have like a model. It's pretty solid, it's promising. So then you want to see, okay, let's take it to the next level. Let's start doing some more validation. Let's start giving it some more data. Here, let's introduce some responsible AI and some explainability to it. Let's put it in cloud. Let's try to challenge it a little bit more. And then if it passes that test and the accuracy is still there, well, then you're talking about starts putting it up there, using your MLOps best practices, incorporating it in your apps, and then it will get really challenging. And that whole process is circular. Of course, you can come back to and then come back after. I'm going to zoom on this piece in here. Like, what do we do exactly in each one of those steps? What sort of analysis do we do? So if I zoom in on this space, I'm going to show you here what does a data science process actually look like? What is it that you do in order for this model to see the light of the day? So here, this is a bird eye view. In each one of those steps is a lot of steps. But let's take a step back. The first one is you need to bring your data, and that data in the best world would be like a consolidated nice CSV file that you can work with. In reality, a lot of data sources may come into the picture. You might have some very challenging type of data like pictures or voice, and you need to get that data in from your data lake, consolidate it. And then comes the pre-processing. So you might see some memes online saying that data scientists, they would love to go to the algorithms and they would love to go directly to the challenging and the fine-tuning, but they spend 90% of their time doing data cleaning. That has some truth to it. So the pre-processing step is also a very important one. The next one is very important. It's called a split. So what you do is that you take a portion of that data to test and another portion to train. So the data that you use to train, you bring it here, and that's the one where you will train your model on it. So you'll select an algorithm and then you'll start training, learning from it. The test data is a data that the model has not seen before. So that's where you will test it to do this. Let's see if that model that generated from here can do well on data that it has not seen before. And then you do your evaluation. You see there are a lot of scores that you can see, and it's a good practice to mix and match multiple scores. And eventually, if that goes well, you start operationalizing. Now, as I said, each one of those steps has a lot of steps to it. So your data can come from different aspects. Your pre-process, you can do some data exploration. When I said data preparation, here are all that you might do. When we talk about algorithms, you can see whether classification, a regression, an anomaly detection, or clustering. So these are the algorithm you would have. Inside each one of them are specific algorithms. You might not know at the beginning which one, but you would know which depending on the problem you're trying to solve, whether you have a classification, an anomaly detection, or clustering. Then you would train it, and this is the piece that I'll delve in, which is parameter sweeping, which is where you're trying to do the fine-tuning, trying to find the right parameters, et cetera, et cetera. So this is what a data science process, this is what anybody who builds a model from scratch is doing. And this is what you would learn if you took a course in data science. So now let's delve into the topic. Let's look into this piece here specifically. And let's talk about model selection and parameter tuning. So when we talk about parameter, every model has parameters that determine how it represents the data. So here I selected a couple algorithms and just some of their parameters. So you could have a decision tree, and you could say how many leaves does that tree have, how many levels, how deep it is. That's also type of parameters. If you have a neural network, we can talk about how many epochs do you use to train it, what is the learning rate that you are using. If you're using a clustering, which basically clusters your data into clusters, well, you can decide this is the number of clusters that I want. This is how I decide that a cluster is coherent, et cetera, et cetera. So this is what kind of parameters you might encounter. And there are more, by the way, for each one of those. I just selected 2 here. And what you would do in your parameter fine-tuning is that you need to find the right value for each one of these to maximize your performance metrics. So depending on your algorithm, there are some performance metrics that you would be using that are outlined here, but let's just say precision. So basically, how much does it predict right versus wrong as what it's supposed to be? So these are a combination that you get to see. So that's basically what you would do, and what is the objective. Now let's look into the how. So now we know we want to maximize the performance, but how do we do it? How do we go about it? 3 steps. The first one is we need to define something called the parameter search space. So you've seen those parameters that I mentioned. They need to have a couple values. Now, you're not going to try everything because you have limited resources and we don't have quantum computing computers yet. So you need to define for each parameter what is the range that we're going to try and iterate of. So these could be like discrete parameters, like say a value from 1 to 10, 1, 2, 3, 4, maybe a fixed value. So 10 or N15, 38, 44. So try these values in particular. How would you know these? Well, maybe by experience, you would know that these are the parameters that work better, or sometimes you don't know at all. So you need to figure them out through your parameter fine-tuning exercise. And sometimes a parameter can have a continuous value, right? So you would use there some distributions that can give you the data. And here I just pasted a little bit of code here, Python, for those of you who like it, just to tell you how you would code that. But in the demo, I'll show you a little bit more. So step one, what is that search space that I need to find so that I can identify my parameter values? Step number two, how is this sampling going to happen? So the first one is grid sampling. I take my search space, I'm going to iterate through all the values. So for each one of the parameters, I'm going to try all the combinations. That's the simplest way to do it. It can also be very heavy and very costly. It depends on the number of parameters. It depends on the value. If we're talking large language models and things like that, you might want to rethink doing that because that's a lot. That can be heavy. But if you have some discrete values, yeah, you could do that. It might take a couple hours. You can sustain that. Or you can take random sampling. Let's take some random values and see how we do. You would do that in general when you're still trying to figure out what is the search space you're going after. Or you could do Bayesian sampling. If so, those of you who remember maybe your classes or Bayes theorem, when you try to build up your current test based on the previous one so you could have better results. So step one, what is my search space? Step two, how am I going to learn through it? The last step here is the early termination. Why is that important? Because your training can take a long time and you don't have unlimited resources. And sometimes what you will notice is that your model, even if it's iterating through different values, the accuracy is not improving. So essentially you're burning resources, but your model is not showing like it's improving. So you might want to stop it then and then go back to it and see what else could you modify. So there's a couple policies here that you can see. If the performance was lower than the one just before, maybe if the performance was lower than the median of the performances you've had before, there are multiple ways to do it, but that's a best practice so you could save some resources. So with that, I think enough about theory. So that's what we do when we do parameter tuning, whether you have a simple model or whether you have a huge model that you're building, you'll define your search space, you define your sampling method, and you'll define your early termination. So with that, let's go to Azure ML. I want to show you in practice what would that look like. So let's go here. This is my Azure ML workspace. I hope you're familiar with the tool. If not, I really, really encourage you to spend some time on it. It's really overarching. It has all the tools necessary for you to do your machine learning project, however the complexity. So just very quickly, you have different ways to author, either through notebooks, automated ML, I'll come back to it in a second. You have a designer, and then you have your assets, and you also have where you can manage all your different resources to run your models. So let's go through it. What I want to show you here is a model that I wrote on the designer. So just to see that experience, but because it's fine-tuning, it takes time, I already run it. So here in this section, you have something called jobs. So this piece of jobs, it shows you all the different runs that you've had. As long as you want to keep the logs. So these are all the models that I did run. Some of them failed, some of them were completed. And when I select one, I can get access to all the data. I can get access to the model that was trained, to the statistics and things like that. So the one we're going to look at is this one, grid parameter tuning for a binary class. So I already opened it here, so we can look at it. So before we go into the details, I just want to show you this designer experience. So remember that first diagram that I showed you about the data science process? So that's pretty similar, right? And I really like the designer because it's very visual, especially in the first circle when you're trying to experiment and you have new people in your team. It's very visual. You can read it and you can go through it, and you can also export it into code because some people, I'm sure, are like, no, I want my Python code. So you can also do that. So let me zoom in a little bit just to show you what this model does. This is a pretty simple model. It's a binary classification on adult census. What we're trying to do here is we have some data about some people, and we're trying to predict a value here, which is your income going to be above 550K, lower than 50K. Pretty simple. No big neural networks needed for this one. Or so we think. So we have the age, the work class, the education, and things like that. And the good thing is that you can also have some visualization already out of the box. So this is important in your data exploration because a lot of the time you have to code those visuals when you're starting. So Azure ML does that for you, so you could see if you have a class that is imbalanced, if you have some missing data, and things like that. So that's something that you can already do. So what are we doing with this data set? We're doing some basic data cleaning. We are removing some data that have missing values. We're replacing some missing values with 0. So this is a very clean data set. If this is all we need to do, in real life, you probably will have 20 steps of data cleaning and that you will work with your data engineer sometime to get that done. But for the sake of it, we just have these 2 cleaning steps that we have. Now, let's get into the real thing. So we're splitting the data. You see here a 0.5. So we took 0.5 that will go to the training. It's here. And we took 0.5 of the data that will come to our test here to score. And here we decided to use, it's a binary classification. We decided to use a 2-class boosted decision tree. It's a very powerful model. Not everything needs to be a strong neural network. I've used this multiple times and it solves a lot of problems. Now, I just used it here. And in general, you wouldn't go and put one algorithm already. You probably would put several algorithms and try which one is the best. But maybe historically, that's the one that you've been using and you know it performs well on this type of data. So let's assume that's the case. And I know that would be a good model. If not, hold this thought for the AutoML piece, where we'll talk about selection of multiple algorithms. So here is classification. Remember when I showed when we were talking about the type of parameters. So here you see how many leaves per tree, how many nodes per, how many samples per node, what is the number of trees that I need to construct, what is the seed so that I can have reproducibility, etc. So these are the parameters that you would see. Now, here is one thing that you will notice. I used here parameter range. So now I'm not going to have one value each. I want to have multiple values. So for the leaves per tree, let's try 15, 30, 128. For the number of samples, for each leaf node, this is 2, 8, 20, and 50, something like that. So this is my search space. And now I will go to this module called tune model hyperparameter over everything. So here I have our best model, which is going to here, and I have my sweep results. But before we go to the best model, I want to see the sweep results because that's what we're here for, right? Hold on, sweep results. Oops, sorry, excuse me. Multiple tabs opened. Oh, there we go. Sorry, I closed it again. Hold on. All this thought. Hello. Oh, sorry, my PC is blocked right now. I don't know what's happening actually. So maybe I'll try to close this. Let me try again. If not, I'll just tell you what happened and then we can move on. There you go. Preview the data. I think we can see it right now. So while it's loading, what I want to show you is that is the different iteration of parameters that that the model has been able to show, and the different values for each one of those. So let's make it a bit bigger. Here we go. So let me go to the last column. And this is the ranking of the different models from 1 to, I don't know, I think there are like 120, so 180. So that's how many iterations. And these are the different combination of the different parameters. So the number of leaves, if you remember, the number of trees constructed, the number of leaves per trees, etc. And here we're seeing the value that we're trying to maximize, which is the accuracy. So it's ordered by in descending order. So the top one has the best performance, and it also looks at all the other values. It's always the best practice to see the different values. So right now I can tell that, yes, that's pretty much the best model that we have here. It's iterated over all of these possibilities. And now from the first circle, I can move to the second circle where I challenge this model a little bit more and try some more validation so that I'm sure that this is the right one to use. And then I can go on to my evaluation and things like that. So for the sake of time, now I'll just move on to another site. So the thing that I mentioned earlier is that I chose decision tree, right? But how do I know that that's the best? Models could be very useful. And for those of you who've been in the data science for a while, you would remember creating multiple models, iterating over them maybe, and then taking the best one. Now, what we have is something called AutoML that kind of does that for you. So what does it do exactly? Let's take that same example. It will help you do three things. First one, it can automate some featureization and feature engineering. So it means it can go actually to your data, that data pre-processing piece. It can actually take some decisions to clean some data and also create maybe some new features that would be optimal for your data, for your analysis. That's called feature engineering, creating new features from existing ones. That's the first one that it can do. The second thing that it can do is algorithm selection. So we were doing a binary classification. So it could be a vector machine, it could be a logistic regression, it could be a decision tree, it could be a boosted decision tree, it could be a neural network, which one to choose, right? So it will select all of them. And then it will do hyperparameter tuning, exactly the process we did before, the best model. So it does all of that for you. So let me show you one other experience from Azure ML. Now you can use a graphic tool to configure your AutoML to do all the different steps that you see here. So this is what it looks like. The first one is you need to choose your data set, right? Is it from storage, a SQL database, a local file, maybe web file, open from Azure Open data sets, etc. So that's step number one. Step number two is, if you remember, we need to select what is the family of algorithms that we need to use, right? So is it a classification? Is it a regression? Are we forecasting time series? Are we doing natural language processing? Are we doing computer vision? And as you can see below, here are the type of processing of algorithms that AutoML supports. So you need to select the family of algorithms, and then it will go and do the rest. But I want to show you a couple other things. The second one is, well, this is the metric that we need to optimize for. So the accuracy, but it could be the normalized root mean squared error, which is also one of the metrics for accuracy, especially when you're doing regressions. And then you have this checkbox here, which is explain the best model. I'll show you in a second. This is a preview feature. It gives you some explainability to tell you how the model actually behaves. This piece here is also important. I can check all supported models. You know what? Block some models. There are some models that I don't want to use, either because I know they're consuming a lot of resources, and maybe I don't want to start with these models first. I try the simpler ones. Don't bring me a huge neural network. First, try something simpler, or maybe because you've tried these algorithms before and you know they don't work with that specific set of data, so you have that leeway. And then, if you remember step number 3, which is the exit criteria, like when do you stop, the early termination. So here I can say, I want my job to stop after 6 hours. Beyond that, I don't want to continue. Maybe I need to look, probably there's something that I need to change. And then what is the threshold and how many concurrent iterations that I can have. These are some other things that you can configure. And one other things that I want to show you, validation. How do you want to do that validation? Do you want to bring a different data set in which you want to do your validation, or do you want to take some validation from the data set that you have? These are also things that you might want to do. And then eventually, this as to the performance. For example, this is the ideal performance of the model. This is what we're seeing. So you get to see what is the best model. So that's what you would do in AutoML, and I think it's very promising. It automates a lot of things for you. So let's go to the demo. Let's see how it works. So I showed AutoML in the graphical user interface, but let me show you also notebooks, right? So where you can run your models as well in your notebooks, because I'm sure a lot of you here love your Python code, you love your notebooks, you have your own library, so you want to use it with that. So here I used a notebook that actually you can find online. So maybe I can paste the link once I'm done, so you could try this. So it does a couple things. The setup, so you can set up what are your resources, your compute, etc. Train your result and test in data. So the same machine learning process that we see, albeit a bit simplified here. So I'm going to skip through some steps, important, some libraries, creating a workspace, and then add in some compute. Your machine learning, you can create your own compute or compute clusters. You can decide how big do you want them to be and how optimized, etc. Let me start here. So the first thing we're doing in this code is that we are loading it, and that's going to be our training data set, right? And we have our label, which is the column that we're trying to predict. We call it class, and that's the piece that I want to spend some time on. This is where we configure our AutoML. So the things that I showed you in the GUI, we're doing pretty much the same thing here. So how many cross-validation that we are doing? What is the primary metric that we are going to optimize for? Do we do early stopping? Yes, we will. How many concurrent iterations? Yes, we will. Timeout for hours, etc. Verbosity, yes. So I could have my logs. So that's one thing. So I have this variable AutoML config that I'm putting here. And then I am doing some other things, which I need to specify. I'm doing a classification. My logs, I want them to be logged here. This is my compute target we created earlier. This is my training data, which I have loaded earlier. And this is my label, etc. So this is where I do pretty much the things that I did in the graphical user interface to make it go. And then I keep on running it, and I have some, I run it already, of course, because this took a long time to do. And I have all the different models that are here. But I'm going to go to the jobs section to see it, because I love that view. I think it's pretty, it's pretty visual. So again, if you remember, that's the jobs section where I had my grid parameter tuning. So here we will look at AutoML classification. By the way, when you don't specify a name for your experiment, it gives it like a funny name. So this one is called Placid Pen. I don't know, but you'll find some. It gets creative in terms of naming your models. So I want to show you two things, because there's a lot to see, but a couple things that I want to show. The first one is, well, this is the bust model. It is called voting ensemble. Maybe it's a French word, and it has some statistics and stuff, but we'll look at that in a second. I want to show you this section called data guardrails. So you remember when I spoke about the different steps of AutoML, there is this piece where it actually helps you with your data preparation before going to your training and fine tuning, etc. So here it did some things, right? Some steps that it was able to do. So there were some missing feature values that it made an imputation for. So that's done. Okay, good. Thanks for for replacing my missing values. There are some features with high cardinality. It means that they have very high values. So it's very good to normalize them a little bit so that they don't dwarf the other data points. So these are two things that it was able to do. So done and passed. However, there is one, it gave me an alert. And what is this alert? It tells me that you have imbalanced classes were detected in your input. And when I looked into it, in fact, I do. What does that mean? Is that in your training data, you have a lot more data from one class versus another. You have an imbalanced data set. So be careful. Is it by design? So maybe you're doing an anomaly detection. So the anomaly set, of course, is smaller than the rest. So that's okay by design. So you need to address it. Or maybe not. Maybe you have a bias there that you need to adjust. So pay attention. You don't have some equilibrium in your classes. So that's some data guardrails. I think it's pretty useful. These are kind of things that you'll have to code in general in order for you to see it. But let's look at the piece that's interesting, which are the different models. So it has tried a lot of models, and now it's able to tell me which one is the best. So the top one is the best. We'll look at it in a second. But and then there are some others. So here you'll see two names. The first one is the type of data analysis and that it did, and the rest one is what is the type of model algorithm that was used, like a logistic regression, for example, or XGBoost classifier, etc., etc. So it tried a lot of them. Now this one is the best. It has an average precision of 98%. I'm always cautious when I see 98% because sometimes it's very good when you try it the first time, or when you try to validate, it plummets. But still, it's our baseline model, so we could go with it. And you can go here and you could see some parameters. You could see a little bit more exactly. I want to see the value of those parameters, so you can go here and you can see what is the depth, how many leaves, and things like that. So you can really go into granularity. But I want to show you also some other things. I think I have a bit more time. So when you click on that model, so just to go back, if I were to and try to see what are the steps, so I get to see all the different performance metrics. So by all measures, it's promising. So we could go further with it. I have my curves, my precision, and my recall. These are standard metrics that you would use. So it doesn't look too bad. Your ROC curves, it looks pretty good. And you can see here how you measure it if we were to take something random versus averages and weighted average. So that's also from a visual perspective, it's not bad at all, I would say. The other thing that I want to show here, which is fairly new actually, it's model explanation. So you would notice when I clicked here, if you allow me, there you go. So you click, you see here, there's something called view explanation. So this is in preview. It helps you to understand your model a little bit more. And particularly one piece that I really like, sorry, I can't scroll up, it froze for a second, but at least it got me into the view that I wanted. One of the things that you would always do is feature importance. So I have 100 features in my data set. What are the top 10 that have the highest prediction capability? And what it does for you is that out of the box, it tells you that these 4 values are the one that explain your model the best. And I think that's pretty powerful, because in general, you would code that, you would have that feature importance aspect. So this is good for you to go back to your data set and try to understand what it does a little bit more. So there's a lot more to see. Of course, if we had more time, we could spend way more time seeing what Azure ML provides you. So I really encourage you to give it a shot and try all the different experiences, from the designer to the notebooks to AutoML and all sorts of things. And just to close, going back here, I hope now you this was the for all those of you who've been doing this before. I hope you got to see a little bit how Azure ML is making things a lot easier, and for all the professional data scientists, it can get going very quickly. And for those of you for whom you're new, all of this is giving you an appetite to learn more about data science. I want to close this view is like right now. Let's suppose that voting ensemble model is the one where, well, we just finished this, have a baseline model, great. But the next step is challenging a little bit more. And if so, that eventually we could operationalize it and add it in our app. So with that, that closes what you would do when you would create a model from scratch and do fine tuning with it. The next step is going to be, well, what if you already have a model and it's already solid and big and huge, just like our large language models, and now you need to do another type of fine tuning, which is making it a bit more accurate for your own use cases. And we like to call it transfer learning. Look up this term. So that's what Alon is going to take you through right now. So with that, thank you very much. You can reach me here in LinkedIn. And yeah, if you have any questions, I'll be monitoring the chat in a second. Thank you.
Lila. So I think there are several questions in the chat which are being answered. I don't know, should we spend some time answering them online? Maybe we'll just ask Talila to follow up in the chat if there is something which she needs to she wants to address. And in the meantime, we probably will move to the next speaker. Ellen, I hope you are ready, because I just don't want to take more time. It's just an amazing content which Ellen has prepared.
Thank you very much, Dima, and thank you, Talila. So I'm going to take you through crafting believable AI characters through fine-tuning GPT. This is another kind of fine-tuning that we are going to see on a GPT model. It's a little bit different than what Talila has showed us. Let's jump right in. So first of all, a little bit about myself. My name is Alon Danoch, and I'm a machine learning engineer at Microsoft Defender for Cloud. And I'm also a gamer, and me and a couple of friends, we took a look at how we can improve the gaming experience with AI. And let me not talk a lot about it and just show you a quick video, about a minute and a half, that's going to show you the final product of what we created. And then we'll talk a little bit about fine-tuning, memories, and a lot of exciting things from this field. So we took a narrative of a character from one point, for example, Harry Potter Wikipedia page. We have a few scrapers that takes the data out, the text. We fine-tune the model, and then we get something which is like Harry Potter ChatGPT. Let's see an example.
I got my start when Lord Voldemort tried to kill me when I was a baby. Lord Voldemort is the most powerful and feared dark wizard in the world. Thank you for warning me.
Now, we also wanted to populate our world with with other classes of characters, like orcs, and we wanted to have some kind of alignment, and we also want to create one model that can serve many instances of the same creature. We're going to talk about this in a bit.
You will be for those words. I will make you suffer in ways you cannot even imagine. I will get you like a fish and leave you with me on slowly. I will skin you alive and wear your hide as a trophy. I will.
All right. So, of course, I didn't build this project by myself. We had a big team from all over the world. So thanks everyone who contributed to this project. Now let's talk a little bit about the goals we had in mind when we came to think about this. This was actually before ChatGPT was released. So first of all, we want to speak with multiple characters. We want to create characters that are unique, individual, like Harry Potter, for example, and a group like orcs. We want them, each one of the orcs, to have its own personality and be a little bit different, but not have to fine tune many models. And we want it to be accessible. So as I said before, we have two types. We have the individual characters like Harry Potter, and we have the orcs. And also the orcs can choose their own name, and they have some alignment that we can choose from. I'll talk about this in a bit. Now let's talk a little bit about the issues when we try to do this. So um, we use the GPT-3, of course, and as you know, we have a limitation of tokens, about 3,000 words. Even if we use the new GPT-4, we still have a limitation. And even if we don't care about the limitation, it costs a lot of money to send large prompts, and at some points we'll get stuck. So that's one issue. Second is dialogue relevance. Our characters should answer accordingly to what I'm asking. For example, if I'm asking Harry Potter who's Donald Trump, he should say that he doesn't know. Um, Third is a memory. How you create a memory. In the instance of ChatGPT that we all know, we have some kind of memory. How did they created it? The model of the GPT itself does not contain memory. We need to do some engineering techniques to create some kind of artificial memory for it. And timeline. For example, we play through half the game. Event changes. We want our character to learn about them. How do we handle this? Another big issue that we have is called hallucination, which means that the content that generates from GPT is relatively not true or kind of a bullshit. How do we handle it? That's a big question. For example, and it's not just the hallucination for what it tells us, it's like the relevancy. For example, if I'm asking what's the longest river in the real world, it will be the Nile. If I'm playing World of Warcraft, it will be the Nasafari River. So you get the point. Now let's talk a little bit about the solution. So as I said before, it's a solution that has two sections. First, the fine tuning, and second, the history state. We're going to go into depth in both of them. Let's talk first about what's wrong with just using prompts, right? Because here we have a short example of an org descriptions. I gave it a few examples of what a player would say, what the org would say, and etc. And we can probably use that. But then we are limited with the number of tokens we can send, which means that even the description is going to be relatively short. So this is where we come up with fine tuning. So OpenAI and also Azure OpenAI gives us the ability to take those large language models like GPT and fine tuning using a technique called few shot learning. We can use this through the Azure portal AI or the REST API or even through a Python code, depending what do you like. And it gives us a higher quality result once we do this. It gives us a lower latency of request because we have our own instance of model. And because we don't need to provide a lot of examples when we do the actual prompting on our production, we send less text, which save us a lot of money. So first of all, when we want to fine tune our model, we need to, first of all, actually choose the model. OpenAI doesn't have just DaVinci 3 or or GPT-4. It has a few kind of models that we can choose from. It really depends on the problem that you want to solve. Maybe you don't want to use the latest DaVinci that will cost the most. Maybe your problem is something much more narrow, like classification or something like that. So you might going to consider one of the other models that are available for fine tuning as well. And of course, it will affect the performance and the cost of your model. So how do we do the actual training? So I can say that it is relatively straightforward. We have a structure of a simple prompt and completion. And we need to provide many examples for the model to learn from. OpenAI in the official documentation talks about maybe 200 training examples. In real life, you're probably going to need a few hundreds, maybe a few thousands. closer to the 5,000-6,000 of examples, or even more if you want the model to be high quality. OpenAI is also mentioning that doubling the data sets, that's what gives us the linear increase in the model quality. So jumping from 200 to 300 is not going to do a lot, by 200, 400, 800, and etc. And we can see an example, very small example of the training set that we gave to Harry Potter. For example, we have a prompt with some kind of a biography about Harry Potter, and then we give some an answer, and then a completion, and then we have some other kinds of questions and completions. And also another thing, note that I'm not just sending the text just like that. I'm doing a player and then Harry Potter. This way, it will also be easier for me to extract the text when it's come back from OpenAI API and to insert it into my application. Let's see another example from OpenAI documentation. So here we can see the structure of a prompt. As I said before, we have some kind of a summary of an order of a customer, then a message, then a response, then another message, and the completion is another response. Now, the second example that we have here below show us actually the same thing, but then we add some kind of a third message and a third response. We are kind of preparing the model to understand that we're going to send prompts that are going to build on top of each other, and this is going to help us with the memory, and we're going to show how we're handling everything in a little bit. Now let's talk about prompt engineering, which is also very important, right? As you saw before, I'm sending many prompts as my fine-tuning examples. And for this example, I want to show you the orc. So the orcs are a model that we used on a few different characters. And the way we do that for this example, first of all, we tell him straightforward, you are an orc. You need to choose your own name. That's what gives him the ability to do so. If you will ask him a name, he's just going to generate something. If you're going to ask the next instance, using the same model is going to generate something else. Other than this, we're also going to tell him you should answer question as a person in a group, as an orc would answer. And then we give him some descriptions about orcs. We tell him that he needs to be scary, and etc., etc. Once we have all our examples, we can go to the next section, which is validation of our data. We can take some of our training data and use it as a validation. This is an optional. You don't have to do this. The way it's calculated is more like giving you the accuracy of how similar GPT completed the prompt and how similar it was to the prompt completion that we provided. We can also set the hyperparameters. This is a little bit similar to what Talila showed us. We can choose number of epochs, the batch size, the learning rate multiplier, the prompt lost weight. It's also an optional. I can tell you that we use the default values and it worked pretty well for us. And once we have our model ready, our training data set, everything, we can train it, and then we get our model ready and we can start sending queries to our API. Now let's talk a little bit about memories. How do we save this whole history? So we use the technique of a data structure with a matrix of an array to save all the conversation that we are communicating with our characters. ChatGPT is doing something similar. And as you can see here, even if I'm using the same model, I have two instances for orc number 1 and orc number 2. So for example, when I ask the first one what's his name, tells me Grumash. Ask the second one what's his name, tell me Grishna. And this way, if I'll at some other point going to ask him again what's his name, he already has this kind of memory because I'm stacking all those prompts together, and I'm sending them at one piece. So as we saw in the example that we give to the fine-tuning itself, we are building those questions one on top of the other, and we ask GPT to complete the next one. Now, at this point, some of you are probably going to say, but Alon, you just told us that we have some kind of limitation with this kind of technique of memory, right? At some point, no matter we're using GPT-3 or 4, we're going to run out of space. What are we going to do then? How are we going to handle it? And at this point, where we have some other techniques that we're going to use mostly to summarize those history state that we're going to hold. So we're going to hold the whole conversation at some kind of an array, memory, whatever metrics. And every time we're going to summarize some of it, we can use a different instance of GPT to summarize it, to save it in another array. And then our prompt stack, we're going to send those summarization and the new questions. Now let's see the whole architecture together. So we started with a narrative scraper that goes to Wikipedia, scrape the character's biography. Then we do the fine-tuning as we just talked about. After that, we have our input. For us, it was a C# backend and runs on a Unity engine for our game. And we send it to the pre-trained character model, and we get back the answer from our prompt. We save it in our history. We send it to Azure Cognitive Services for it to return us a speech, so the character can actually speak. And then we get a lifelike character. So that was my session. I hope you learn something from it. I hope I gave you some information about how we did it, how the techniques you can use. Of course, for memory, there are actually more techniques that you can use. I just show some samples. There's also like vectoring database if we have a lot of memories and things that we need to understand and learn and get them into our prompt at whatever time. And thank you, everyone.
Amazing stuff. Thank you, Alan. And there is actually a great question right in the end of the chat. Do you want to address that? Because I think that's connected directly to the presentation. If not, we can address.
Sure. Let me just. Can you please read it for me?
Yeah. Given large body of interconnected text, such as organizational docs, how would you recommend converting it to prompt completion format? Is there a tool by Microsoft to work with those documents?
First of all, GPT-4 can actually handle a lot of pages altogether. So maybe you want to consider that if that's the problem that you want to do. If not, maybe try to summarize just part of it and then work with different kind of parts when you're using the prompts. If you do the fine tuning, maybe take sections, create some questions and answers from these sections, and by that create a very, very big training data set that will have all your pages, all the book, everything together. And it will save you from prompting this whole thing because you can use the already fine-tuned model that you just used, and you can just send shorter prompts for it.
Yeah, so actually Roman, who asked this question, has just, you can see now there's the question on the screen, has clarified that the question is how to make it into prompt completion.
Do you mean how to break it? Like if I have a book, I want to break it. So how do I create a training data? Is that the meaning of the question?
So Roman, we are trying to understand what exactly you mean. Let me try to, from my perspective, to give you some insights, because recently, especially if you watched a couple of days ago, the build announcements, there was a lot of interesting news coming from Microsoft tooling. One of them is in Azure OpenAI Studio. You will be able very soon, and there is a preview already which is coming, and you could see this on build, like on live demos. So you will be able to say, this is the documents which I want to feed into this particular model so that it starts answering your questions. I think that's what you mean by completions, answering your questions on those documents. So there are techniques how to do it. Again, Alan just described them. Usually it's just either like vectorizing that answers, like doing the applying the techniques to make this representation of those documents searchable, and then search through them, extract the text pieces which are relevant, and then make the summarization based on them. Or again, in this new tooling which is coming in OpenAI Studio, you will pretty much be able to do this with several clicks. Just say, here are the documents which are connected to this query, go answer the question in those documents. So that's exactly like $1 million question. That's exactly why customers are so excited about this, is because you cannot just ask these models about what it knows, but you can actually, with Azure OpenAI, you can apply it to your own documents. All the questions are coming like very fast. Is it better to use English for fine-tuning and then translate the user input prompts?
Haven't tried, I'll be honest, I haven't tried other languages. But from my experience with the GPT-4, for example, it can handle other language pretty well. So I think it's might gonna work. You don't need to do the translation and all that. And I also want to add about the previous question, another technique that you can do for creating this set of question and answering from like a book or something is feed it to some kind of GPT and ask him to divide it to question and answers. It's maybe kind of weird that we're going to use two models to kind of talk to each other, to learn each other. But I know a few instances who did this, and it usually worked pretty well as well.
Yeah, I love this approach which we have now with those language models, because they are multilingual by default, but nobody, or not often, we don't know how it will work in specific language. Is it better to translate, or does it really handle this particular, Croatian language well? And in many cases, it's just a question of trying and making sure it responds for your task. Sometimes you might need to do some smart prompt engineering to really get the responses you need, but it should be able to handle questions in different languages and answers in different languages. Depending on your task, it might be or might not be better to translate, I would say. Okay.
I see another question from Gabriel that we can answer.
Sure.
So Gabriel asked how the classes, the orcs, for example, was created at the same time. So yes, we actually created only one model for the orcs. And by using the technique of the memory, we create different personalities. Another thing that you can do, that every time, for example, that you go to talk to a different orc, you can even generate some short prompt just for this orc, so it will be even more unique. So it has the base of orc ChatGPT, and then some short prompt that we also always going to send to it that tells him, for example, what's his name, what kind of race inside the orcs he is. But it will give us like similar results, but a little bit different. So this is how we can populate a gaming world, for example, with a village of orcs with just one model.
Great. There is a heated discussion about Hebrew in ChatGPT. And again, if there is an enterprise application which you need to apply for Hebrew, you can actually do this with Azure Translator. So Azure has a pretty significant and broad set of AI services, including speech-to-text, text-to-speech translator, even customizable like translator, which can be, by the way, fine-tuned with your specific text corpus. So for some enterprise or government applications, it might be better to use those services. So in many cases, when there is a customer use case about specific, question with specific language and specific task, we might come up with something which is not necessarily OpenAI based, but yeah, those models can perform better or worse in some languages. There is a question which I cannot even... Yeah, there is one on the screen right now for you, Alan.
No, we did not use the semantic kernel for this project. We used the Azure Open API. DaVinci 3 was actually, it was before GPT-4 was announced. And as you can see, the results are pretty good. And I would just say that when you starting this kind of project, like the cost of it is something that you might want to consider. So using not the most advanced model might save you a lot of money and give you good enough results depending on your project. So another question from Gabriel, do we continue to fine tune? So this is something that I actually talked a little bit about at the beginning. What do we do with the timeline of the game? So the answer is yes. We can actually, once the game, for example, events are happening, we can continue this fine tuning on those models, maybe even create new models for the orcs, but we can continue them, give them more examples, do another iteration, and then teach the model new events that happen and how we should respond to them.
I'm not sure if anybody or if somebody on the call can... my stream counts the most... I cannot read this even.
This is like a Hebrew. All right, so we're asking that ChatGPT is kind of very straight to the point, I would say, bot, and it's asking how we can create something that is not so straight. So when you're using those models and doing fine tuning, they have less. For ChatGPT, you cannot, for example, curse it. You cannot ask him to give you some offensive answers. Those models are less restricted, so you can use those. And as I saw with the orcs, we told him that he should answer like an orc. He should be not nice. And if you saw the video at the beginning, he actually tells me that it's going to kill me. It's going to do a lot of bad things to me. So this is how you do it. You just feed it with what you want him to answer and tell him to be evil or not nice to you or whatever.
Nice. I love the question now on the screen.
Is ChatGPT able to generalize the whole data set based on only a couple of hundreds of Q&A pairs? So you probably need more than hundreds. You need thousands of examples for having a good model. It will work with a few hundreds, but you will find out that at some points it's not accurate. It tells you a little bit of mistakes. Maybe it keeps telling the same thing. So probably go with the thousands and maybe even more if you can. Again, quality training data is the key for machine learning. So
yeah, I'd say that if I can add to this, Alan, because I'd say there are several scenarios where it might work. For example, if you say to, if you use the concept extraction capabilities of those models and just say it in which format it should answer. For example, you give it the Q&A pairs, which are like, if the customer asks that, give them answer as a JSON. If they ask this, give them answer as JSON, extracting like entity and whatever from this. If you give this some examples which use its internal language capabilities, but you just kind of teach it to extract or to generate the right things out of the data in the right format, it can learn from even several examples. But if it's really you want to teach it to do a conversation differently, I think you'll need more than that. Amazing. I think we have addressed several of the most active questions. I'm not sure if we missed something. If not, should we ramp up now?
We haven't finished yet. We have additional guest that's gonna join right now. His
Okay.
name is Moshik. He's from the Moshik Shir from the Fast Track team, and he will present to you some main questions that we get from customers, like what is the difference between OpenAI and Azure OpenAI? How you can also get the support of Microsoft and to answer the questions that you have, and how can we help you to continue to start or go live with your amazing innovation incorporating OpenAI. So moving to you, the floor and the stage, Moshik, and we will shortly share the screen.
Wonderful. Thank you very much, Adi, and brilliant session. Let me introduce myself, Moshik, Program Manager, ISV and Digital Native Center of Excellence. Let's move to the first slide. Many questions are coming to us about Azure OpenAI versus OpenAI. And what we wanted really to call out is that Azure OpenAI is overall in the Azure machine learning platform. Can you show the next slide maybe, or the slide that shows the platforms? And it's overall in the overall cognitive services model. So the Azure OpenAI really side by side with the decision making, the language, the speak, and also the vision. For each one of the applications, like Microsoft 365 and Dynamics 365, we also enable a Copilot, and it's in progress. So you heard more about it in the previous Build Day conference that was happening last week, and more coming. Can you share maybe the next slide for the Azure OpenAI? Okay, I'm not seeing it yet. Yes, indeed. And then, okay, so that was the previous slide. Thank you very much. So here you can see in a very easy way where Azure OpenAI sits in the overall Azure machine learning. So the way that we're looking at it is from business users and also developers. So many on the call today are part of the developers and machine learning and data scientists. So we have several models that are part of the cognitive services, and we could look at it also from scenario based. So it could be that you would like to use the Azure OpenAI under bot services or cognitive search, form recognition, and more examples and scenarios that are showing up here in the slide. Let's move on. So the main differences that we're seeing between Azure OpenAI and OpenAI is that Azure OpenAI co-develops the APIs with OpenAI, ensuring compatibility and a smooth transition from one to another. And this compatibility is going to enhance in the future even furthermore. With Azure OpenAI, customers get the security capabilities of Microsoft Azure while running the same models as OpenAI. And also Azure OpenAI offers private networking and regional availability. So many areas are now open, like West Europe and also US and APAC for Azure OpenAI. In the next slide, you can see in a very easy way also what's available in Azure OpenAI versus OpenAI API. So the security and the reliability, the VNet, the role-based security, the compliance, the data security, the billing, dedicated resources, as well as transactable base. And also another main difference is the safety system and control sensitive words, classifiers, and allowing block and lists. Help us shape the future of Azure OpenAI by answering this survey. So you could scan here the barcode, and in 2 minutes you could see a few questions that we crafted together with the product team to really bring your ideas, your thoughts around what's supposed to be the Azure OpenAI in the future. So that could be very helpful and informative for us to consider looking forward. So thank you very much. And we'll send it also as part of our survey. Appreciate your time. Bye-bye.
Thank you so much, Moshik. And we hope that you enjoyed today's session. And if you do, or if you, I guess that you enjoyed, but we always strive to get better and to get some new materials, new ideas, to get your feedbacks on our series, on this specific session, and please help us improve so we can give the best content for you. And with that, let's see if Dima is available. Okay, perfect. Okay, so we wanted to say thank you, everyone. Thank you, Dima, for hosting this series. Thank you, Talila. Thank you, Alon. Thank you, Moshik, and the team behind the scene for answering all the questions. Last few words, Dima?
No, first of all, thanks for joining us, and thanks for your interest in Azure and AI technologies which come from Azure. We are here to support you, and our partner network, our experts are always happy if you have like the questions which you don't have answered yet, or you thinking about some use case which you want to apply in your organization, your application. Come to us, come to our partners. We are always open to explore what cool stuff can be built, because we are just a platform company, but it's really the magic of things which are built are in your hands. So happy to partner with you on this, and thank you very much for being with us today.
Thank you. Bye-bye, everyone.